All right, so this is our third live session for our third DevCamp, and we are super excited that you all are joining us. And to get started, we'll just do some brief introductions. My name is Mickey, and I am Director of Operations for Holo, which means that I do a lot of work to support our team and build more of the organizational infrastructure that we need to be able to do things like this. And I love that. I love actually getting an opportunity to step outside of the operational role and connect more with developers in our global community. So thanks for having me here. And we're also joined by Micah. Micah has been on the team from the very early parts of the Holo project, and he does a lot of work in customer service and has played a lot on our HAPS team as well. And so he's here as Zoom host.
Oh,
and then, yeah. And then we also are joined by Bear. Bear, do you want to introduce, or do you want me to?
You can introduce me, thanks.
So Bear is our, what is your title?
I don't know.
I should know you. Oh, okay. So what Bear is really great at is helping, is really leading and facilitating in-person events and group things, and really loves to focus on what kind of experience we're providing for ourselves and our community. And so it's been great to partner with him on our DevCamps, which are our experiment with all online community building. He also runs and manages our hackathons and meetups that happen all over the world. And then we are also joined by Connor, who popped in for a second. And Connor is one of our, hey Connor. So Connor is our primary documentarian and has really been working closely with the Holochain dev team to get us to the point where we are now and to help make the technology more accessible to more people. And so those are some brief introductions a la Mickey. And to get started, I think it would be great to actually do a little bit of a check-in on how the content is actually going so far. So what we're going to do in this session is check in on the content, and then we are going to spend a lot of our time actually answering questions both from Connor and from Arthur, who's going to be joining us in another few minutes. And so I want to focus a lot of the Q&A, especially about some of the deeper architecture of Holochain or long-term vision for Holochain. I would like to leave those questions for when Art can join us. But I do want to see getting through all of the content that we've been sharing with you, how that's going and what that has been like. And so I would be so grateful if someone would be willing to share like where you are. Are you still in day 1, day 2? Have you made it all the way through everything and you're zipping right along? Where are you and how's it going so far in completing the lessons? Who would like to share? If you would like to share, just unmute. Yep, thanks, Peter.
So I have enjoyed the content. I've made it through most all of it. I am still putting some polish on my little other thing that I'm playing with. But it's been good. It's been good to get hands-on. I've appreciated both the breadth and the hands-on. So just the trade-off between what's provided and what you can still do yourself. I did find on Moodle with one of the pieces, one of the sessions or lessons, I think it was on the how to contribute. After I watched it or read it the first time, when I went back, it wouldn't let me back into it. So I could not go back to that how to contribute piece. But other than that, it's been good and I've appreciated it. Found it valuable.
Yeah, thanks so much for sharing. And Peter, is this the first DevCamp that you've done, or you've done this before?
This is my first DevCamp.
Okay. Cool. Who else? Any places you're getting stuck?
I can
Yes.
share if you want.
Please.
So I read almost. I think I read all the technical documents, and so I am now in day 5. But I still have little issue with learning Rust because it's the first time I use it. So there is some kind of syntax or declaration, something like this. Is I need to search a lot to write my own code, because if I read, for example, Connor's code, it's okay. I can understand what he want to do and I can read it. But if I start from scratch and I want to write something, it's still a little bit difficult for me. Need to practice more Rust, I think. That's where I am.
Yeah, cool. Thank you for sharing. Who else?
Yeah, I'd like to go next.
Thank you.
Yeah, so my experience with DevCamp so far has been great. Like, I made it to day 5, and like I'm working mostly on the backend stuff right now, looking into Holochain stuff. So I'm not concentrating much more on the UI side. Like, I'll figure it out later as I have my content, so I can figure it out later. Like how do we integrate an UI to the backend? I mean the Holochain backend. So yeah, it's great. Like I found that although Rust is a roadblocker for most of the developers who are not familiar with Rust, I mean Golang or Rust. So yeah, that's obviously a roadblocker. But like the level of abstractions, I mean the Holo team has put in with the development of Holochain has been magnificent. Like I found it quite comfortable. Like getting used to the pattern of how code has to be written for developing applications on Holochain. So I found that quite interesting, and especially I'd like to mention Connor that he has done a great job on documentation. I have like that is something very verbose and this excellent documentation I have found ever. So that's quite interesting. Like that I refer it a lot. I refer it a lot for developing a few of my play holochain applications right now. So yeah, overall it's awesome. Like it was my first DevCamp and I found it quite good. It's great.
Good. Thank you so much for sharing. Is there anything so far that that you have hated about how we've structured the content, or any piece where you're just like, ugh, I hate that so much?
I can share something that I was remembering the first time I was learning PHP, and I buy a book, it's a book like this, and it's step by step. You start by hello world, and slowly you adding something, question, etc. And I was thinking maybe you should make, like, before starting the course, like a small documentary about step 1, step 2, about a small hello world application, then something like this. So when we get into the first day, we have already a bunch of knowledge about how to start, maybe. I think Mickey is off, and Eric, your microphone
And
is
I'm
off.
muted. Very well done. Thank you. Thank you, Fabian, for sharing. Appreciate it. So Mickey's frozen. She can still hear, which is pretty cool. Just her face is not moving. And this is happening in real time too. She's texting me that she just physically can't move all of a sudden, and her surroundings have gone completely still. It's kind of like a sci-fi book where she is. It's a joke. Thank you, Micah, for getting that it's a joke and finding it funny. It's really hard to make devs laugh. I don't know if any of you have had this experience. It's just really hard to get devs to laugh. So,
I wonder if Peter is feeling the same way.
yeah, Peter was freezing in solidarity, pun intended. Let's keep moving. So I want to invite the next set of questions, or move into what questions does anyone have about the technology up to now that Connor, that you might be able to answer, so that we can explore like things that are coming up for you as you're going through what you're learning, things that you might want to explore deeper that aren't necessarily covered in the course material. So what we want to do is structure it so that Connor can answer technical questions around the material that we have now. When Art comes in, then he'll answer more questions related to currencies and meta currency and Scepter and the different projects and the vision aspect of things is kind of the plan that we had set for today.
Also, just to add to that, there are some aspects of holochain technology that are still theoretical and not implemented, and that's you guys. Some of the questions that you all are asking are related to that status, and those are also really good questions for Art, because he will be able to explain and get more into the details of a thing that right now we can't show you because it doesn't exist, or it's not on the release, and so those will be fun. But sorry to interrupt. Please, technical questions for Connor.
I can just, maybe it's more of a request than a question, but handling entries would be really good to have some sort of walkthrough or video of people coding about how to actually pull an entry out and use some of the content of the entry, and then put it somewhere, like this whole unwrapping and wrapping, and that's in Rust. That's kind of for me, that's been really efficacious. That'd be nice to have some sort of tutorial with. I
can actually speak to that one. That's something that we're working on, and that is going to be coming about in the coming weeks. There'll be more coding videos of people working on Holochain talking about it as they're doing it.
Oh yeah, were you mentioning videos? Yeah. And it's really tricky with videos too, because Holochain's been evolving so quickly that when we've made videos in the past, they go out of date so quickly that that they're kind of more of a detriment than a benefit. But we're starting to at least hit some stability on some of the pieces, and also there are some pull requests in the queue for Holochain, Victor, that make handling entries and getting the data back off them much easier than it currently is, because we feel it like that's something that every developer probably wants to do. So it's not something that it certainly shouldn't be a thing that's difficult. So there will also just be the process of just improving the API so that it's like not such a hassle.
Along those lines, I read at some point there was talk of GraphQL, and do you know what sort of the direction is for that sort of approach?
Yeah, there's a couple different sort of lines of inquiry about how Holochain could play well with GraphQL. One was done like just in the Zome side, where somebody actually created a Zome that used a Rust GraphQL library, and it actually worked really, really well. Just putting the GraphQL library into the Zome side. But also we were thinking about the potential for there to be deeper integration with GraphQL that the HDK would support, which would mean that you could just, that potentially and it would just be an option, you could use it with GraphQL or not, but but there would be an option where you could define your schemas in a GraphQL-like syntax, and then be going straight into kind of development based on that, those specifications and schemas and stuff. So, but currently, we've sort of researched and spec'd it, but no development has begun on that yet.
Okay, I could see that lending itself to some cool visualizations of different apps out in the wild.
You mean through the kind of GraphQL interface?
Yeah.
Yeah, totally.
Any more tech questions or questions about the tech? And the next step,
Yeah, I just have a quick question regarding the release cycle of the option. I mean, if I capture the 0.0.4 alpha version and start developing my application on top of that, so like how long will it support? Like, is there anything that anytime soon is it going to be deprecated, just like earlier version of Holoproto, or in the long term, like will it support for a couple of years? Like, we'll have support for a couple of years for 0.0.4, or like what do you suggest? Like, where should we actually decide like this should be a stable release and we start developing on top of that?
Yeah. Well, it all depends like when you really want to get into it and when you want to what the sort of willingness to keep up with the releases, with the release cycle is. At this point, because we're basically still what we would consider pre-release, there's not really promises being made around full backwards compatibility. So typically there are breaking changes between releases, and that will probably be the case for the next few months until we get to we will clearly state what is our first stable long-term support release. And also we're working on stuff that makes it a lot easier to check and compare versions, because versioning is actually even more sophisticated and somewhat made to be somewhat complex when you get into running this decentralized system instead of a centralized thing, because everyone has to run it on their computers, and everyone could have potentially different versions. And so we want to do some sort of provide some tools that check versions, and make it so that it's a lot easier for developers and users to like make sure that they're running something that's compatible and that kind of thing.
Okay, got it.
I had a question about distribution of the actual code. Do you guys have you guys thought about actually using Holochain itself to distribute like the UI front end code and the DNA code as well, kind of like BitTorrent style or something like that?
Right. I forget what the latest is. We do have something sort of in the works that we call HCHC, which is the Holochain of Holochains, in the sense that it does actually store, it's kind of like a directory or something along these lines for discovery and sharing of DNA and those kinds of things. But I'm not sure exactly what the we'll have to solve the entry size thing first, which will be how big an entry can you actually save into the chains before we can potentially like distribute anything that's kind of larger like that within across on a chain.
Cool.
I have a quick question. I tried to upload. I'm searching for the source code, example source code. uploading photos or videos, anything, the files, binary files. Is that in present version of Holochain, is it possible to hosting the files right now? And if it does, how do you crypt in that? I mean, if you upload into distributed hash table, maybe everyone can see it. But if someone uploaded as a private, how do you crypting it?
Sorry, I lost you at the end. Can you repeat just a bit at the end?
And how do you achieving to encrypting the files cannot see others if it's uploaded as a private?
Yeah, I was cutting in and out a bit, but I'll try to mirror it back to you and see if I got what you were saying. Are you talking about private entries and what exactly happens with private entries, or is the question more about encryption in use for the creation of public entries?
It's I asked about the files. If someone uploaded the files to the holochain, how does it encrypted or just make secret from the others for the files? Yes.
Yeah, so at the moment there's not encryption in terms of like creating entries, but there will be that. Of course, you could always encrypt something before writing it as an entry, but that wouldn't be as easy as it will be, where you'll be able to create encrypted entries relatively easily. But also, in order to store, this is the same issue as I was mentioning before, we're still working on allowing for larger entries, which you would probably need in order to manage, in order to hold any mid-size files or larger. And once it's there, I mean, it's just typical of encryption. You would need to have the right person have the right keys in order to decrypt the entries and to be able to read the messages. There's also just the private entry types, which are entries that technically they only store on your computer on your chain, and they're private from everyone else. But I don't think that's necessarily relevant to what you were asking about.
I don't pretend to know how HoloVault works exactly 100% yet. But can you also get some kind of form of encryption just from kind of your profile being in a separate app as well, and bridging across apps? Is there some level of protection or privacy protection there as well?
Good question. Well, I think there it's a little bit more about access or not. You'll either be prevented or allowed to retrieve information across a bridge from one DNA to another DNA. So if you have the right sort of capability token, then you would be able to retrieve data from the other one. But if it was encrypted, you would still need the keys to decrypt it. But I think that also because you're already in a system where everyone has public keys there as well, then I think it's quite easy to specify the agents who you would like to be able to read the thing that you're encrypting, because you would just specify them according to their public keys, and they should be able to decrypt it with their private key that is the pair for the public key.
Does that answer those questions sufficiently around file storage and encryption?
I wonder whether, forgive me, I'm not sure fully how to pronounce your name, Munkbat, how, whether you meant file storage specifically, because someone, for example, mentions in the chat that potentially for file storage, you may want to partner a holochain application with something like IPFS, which is the Interplanetary File System, which is like great for large files and that kind of thing. And there's actually really interesting things that we think that you could do by combining these distributed technologies. One that's more aimed at file storage than holochain is, which is less like, it's less built for file storage than it is for other types of data exchange and storage.
Mm-hmm. Okay, thanks.
Sorry, I have a question that is possibly a holo question, not a holochain question. It's regarding URL schemes. If I develop a DNA that links to another DNA, and I don't have a app that supports that DNA sort of installed, are you planning to support some sort of discovery that enables me to do something similar there? That if I click a link, I will get an option to install an app that supports that DNA.
I think I know what you're getting at. Like, we have considered, like, there's always the option to fall back on internet infrastructure to distribute like files or that kind of thing. We're also interested in alternatives. We had one of our devs, Nico, write up a pretty fun article that outlined like how you could combine and build a really interesting kind of user interface for holochain apps where you could see lots of different types of data in your user interface, but if you saw a type of data that you didn't have sort of a module or a plugin or the right DNA to support, then you could click it and then it would install it. And then you would also be supporting that particular data type and the DNA to back it and that kind of thing. So those are ideas that we're interested in. We don't have a predetermined or built solution for such a thing yet.
Okay, cool.
Thank you. Thomas is ready with a question.
Yeah.
Yeah. I know that Junto is going live in like 3 days, and I know that Holohost is not going to be live at that point. How are they doing their hosting? I mean, I guess, are they just providing their own devices and they're hosting themselves? And, you know, is there a way to be part of that hosting system, or what's your understanding? I guess it's trying to understand how that all works if they say they're going into alpha, you know, in 3 days' time.
Good question. I have been reading about Junto.
Are they, yeah. What version, I guess, are they building on? And I haven't read what much about it.
I'm fairly certain that they're building on the same version that you all are building on, and at the same time, we know that there are some limitations to that. So I believe that when they say that they're going into alpha, it will just be it will be that they are starting to actually test their technology. That's what I'm presuming that means. It's we don't quite have all of the pieces assembled to go into a live, fully live holochain test net of any kind yet. Like, for example, the networking is unless you utilize a virtual private network, the networking is limited to a local area network. So obviously, you're not going to be able to network across geographic distances and boundaries unless they were running a VPN. And you could technically do that as a way to prototype the technology and run it in at this stage of alpha, but I don't think it will be an open thing yet, and it will be fairly experimental. And we're all gonna be. They work a little bit with a couple of the Holo teams, community support and community like developer community people who keep them connected and are supporting a little bit of what they're doing. And we're really interested in supporting all of you in similar ways to stay connected to the developer community. And we have a couple of people who in particular are really fostering that community and helping to support the different kinds of projects in the way that you might want to be iterating from now and going forward, and with the evolution of networking and the different parts that you're going to need to take these things live. Is there anything else? Did I answer your question, Thomas?
Oh, I think that answers my question. Yeah, I can see that they're just going to run their own sort of back end for a while and not worry about the networking part. But then that kind of does lead into another question with HoloHost. And that question is, obviously I've read a while ago that there's going to be these sort of like master nodes or something, or maybe I'm dreaming this, but that are going to, because as I've played around the networking part a little bit, but they're going to look to an IP address to find out where they should go and, in the gossip network, where they should go and find other peers.
Mm-hmm.
Are there any type of rules on how can you explain a bit more about how that's going to work in HoloHost?
Yeah, and it's going to work a little differently at different iterations too, like different stages. Like for example, there's an architecture to the very close at hand closed alpha version that we're going to be starting to test. There's an architecture in play there that's really only a temporary architecture. It's meant to help us test parts of the system while sort of simulating or mocking other parts of the system. And so in terms of the networking is one of the areas where that's the case, is that we it's quite complex. I couldn't go into the whole thing right in this minute, but but with the networking, there's different types of architectures that you can have. Like you say, there's the one where we have these kinds of the one with which we're going with in the interim is that you have these relay nodes where nodes that want to gossip and connect, they connect via WebSocket connection to the relay nodes, and the relay nodes act as a transport in between the different peers. And this is useful in the meantime too, because it gets us around the what we call the NAT problem, which maybe you read about in the mention of the NAT thing in the networking, which is the network address translation. And this is a challenge because most people run their devices like on Wi-Fi, and so they don't have a port that's easy to connect to. And then there's also the issue of like firewalls and that kind of thing. And when you're connected to like a university network or a company network or any kind, there's lots of networks that have firewalls. So the relay approach bypasses for now the firewall problem, but it also introduces a type of centralization that in the long term we're keen to avoid. At the same time, if we democratize the ability for anyone to run a relay node and and then those relay nodes become end-to-end encrypted, which they're intended to be, but they're not yet, then that may be a robust system that lots of people choose to operate their networking, their networked apps in that way.
So, no, thanks for that. That makes sense. So I just wanted to use the term, this is the first time I've used it in my life, technical debt. There's going to be a bit of technical debt, and then pay back that
yeah. There's some, exactly. There's parts that we're implementing where it's like we're gonna end up tossing out that code. Like we're writing code that we're already planning to throw away. But that's just part of our process and the kind of timelines that we're trying to meet. And in the long term, we also have a commitment to doing things the right way and the robust way and the way that meets our values and standards too. Kevin?
Yeah, so then referencing the gossip protocol, would it be theoretically possible then to write your own manually, like for a HAP to just write its own gossip protocol that other membranes could then use if they felt the necessary, or is it going to be a native gossip protocol? Because there was a trigger function mentioned in the white paper, but there wasn't a description of it, so I was just trying to get an idea of what that looks like.
Well, the whole stack is fairly modular in the sense that I could imagine that parts could be rewritten to function in a different way. That said, you would have to do a pretty deep technical dive to rewrite parts of the gossip piece to work in a different way. But there is an intention to, from the outset, to make the stack fairly configurable as well by the developers, like by Zome developers, like so that you can just say, like, for example, and this isn't in yet, but you could just say what type of resiliency factor or redundancy factor you want to exist in your particular application, which would be an indication of how many copies of a given entry of data should be stored across the nodes in the network at any given time. Should it permeate through 100% and everyone should store 100% of everything, or can everyone hold a small slice of the data? And all of that stuff should be configurable by the Zome developers, and that's the intention.
Okay, cool.
Which actually is configuration of the underlying gossip protocol. It should be responsive to the configuration that's provided.
Okay. So are there details yet on the configuration, or is that one of the theoretical parts yet?
That's one of the parts that's still emerging. Yeah, it's right now. What we have operating in operation is a full sync DHT, which means that right now everyone is storing every piece of data. Every node is storing every entry. So that's the initial version, and then the upcoming releases would be implementing these types of configuration options and the non-full sync DHT ability.
Okay. Great, thank you.
Yeah. Question in the chat. Okay. Is Hollow a good option for chat applications? Something like Slack, Rocket Chat, or Mattermost, or are DAGs better in serving the decentralized purpose? Decentralized chat implementations. Are DAGs better or DHTs for the purpose of developing a decentralized chat application? I don't know that I could speak to how well a DAG type architecture would serve for a decentralized chat application. I think it would just seem to be context specific in the sense that usually with a holochain application, we can sort of imagine that there is a community or a membrane, some type of semi-predefined group of users who are going to use the application, you can have something you could share it open source and anyone could join. But so I'm just thinking that there's the potential that this other architecture could be better for ones that are more like like the architecture of IRC or something like that, where it's just anybody kind of opt in, anybody shows up, anybody leaves. It's a little bit of an anonymous free for all. And Holochain, with Holochain, you bring your identity, so or you bring in identities. So there's a little bit of a different architecture, and I would say that Holochain would be better suited for that type of chat application. And another one, what's the current largest file size that can be stored on Holochain? And is it correct that front-end code is actually stored on number of nodes, numbers defined by dev, aka redundancy? I'm not sure what you mean by front-end code, Clem. Front-end code stored on number of nodes. Would you clarify? Well, I'll speak to the first part, which is about the current largest file size. So initially, we were working with WASM WebAssembly, and initially the file size, or the size was very small, but that's simply because we were working with a single page of WASM memory, and a single page is 64 kilobytes. But the theoretical maximum of that you can grow the WASM memory to is 4 gigabytes. We haven't grown it to 4 gigabytes. It's a theoretical maximum. So far, we've tried and pushed up to like 10 megabytes. But I do believe that we're going to be able to get beyond that. It's just that there's still sort of I think it just requires more time and effort for the dev team to concentrate on that, and to make it a priority, and to do a little bit more research, investigation, development into that part of the stack. And the idea, actually, right now in the HDK, you have the ability to grow the WASM memory size, and you have to do it manually. But in the future, the HDK should intelligently grow and shrink the memory size that's required for entries according to the size of the data that's coming in. But it's not there yet. So if you want big entries, you have to dig into a part of the HDK that's a little bit, that's a lot more complex and requires a lot more involvement. I could point people to it if they were interested. Yeah.
Connor, I think, yeah.
Thomas?
I just wanted you to know, the question that was being asked got clarified in the chat, if you saw that.
Yeah, okay. In case of Goer 4000, it's a React code from day 2. Yeah. Okay, so just on that note, we actually intentionally wanted to sort of loosely couple and in a way decouple the user interfaces from the DNAs, because we envision the potential that for a given user interface, maybe there's 3 to 4 DNAs that actually that UI interacts with. And so in the spirit of keeping them kind of smaller and modular. And so we don't necessarily hold to the idea that a UI folder and a DNA folder always couple one-to-one. So we're going to probably be avoiding that assumption in the baking that assumption into the code. That said, of course, we want to find good and efficient ways to distribute the front ends and specify which DNAs the front ends expect. So it will be more of a kind of this UI is compatible with that DNA and also expects this one and that one kind of configuration. But the distribution options for the UI aren't necessarily on the chains itself or in the DHT. For now, we're expecting a different type of delivery system. And Thomas, you got to sort of follow up.
Yeah, I was just asking, when using the commit function on the Holochain developer kit, I haven't seen it yet, and maybe this is my immaturity about it all. Where do you, and I've read up about the resilience number, and I know that's going to be part of networking, where you specify how many times you want that data to be copied to other people and managed. Is that not, that part's not implemented yet, or is there an implementation of that part?
Right, no, that part's not implemented yet. No, that's the part where right now, you'll see in the app.json files, there's a section called DHT, and that's where that configuration will go in, right in the DNA itself, in the app.json. But then right now, no, the options aren't there because it's just DHT, full sync DHT right now.
So you'll have options in the DHT JSON file to specify a resilience number for just the whole zone, or will you be able to also specify individually for endpoints?
Right. I believe that in the initial conception of it, it's at the level of the DNA, but it's worth actually inquiring into the needs that developers have in a little bit of a deeper way to see whether it's actually at the commit level, maybe, or the zone level, or something more granular, fine-tuned. That's an interesting question.
So you probably have time for one more question in this sort of mode, and then we'll have Arthur jumping in, and we'll change gears a little bit into that discussion. So last questions? Yeah.
I just want to ask about how data are stored in DHT, because I remember this is about the gossip, wherein when I post the data in DHT, some other nodes in the network should hold it so that there's some sort of redundancy. In terms of security purposes, will these nodes who hold the data, my data, will they have access to it even if they go offline, or will they have no access? Because if I understand it correctly, there's going to be some sort of validation that will be run in order for these nodes in the DHT to access data in the DHT too. But will they have access into it once they go offline, or will they lose that access?
So yes, they will have access. The only way that the only type of way that you could obscure the information from them is through encryption. So it could be that they could store a copy of it on their device, but it could be encrypted such that they couldn't read it. So that would be the only way that you would have data that's stored on someone else's computer that they couldn't directly read, that they couldn't just open up those files or look in their database or that kind of thing. Because really, in a way, you are creating a trust net in a sense, where for a given network in which data sharing is happening, everyone is consenting to their data being held by the other peers in the network, and so there is sort of a sense of trust that's required in that context, I think.
All right, thank you.
Thanks for your question, Victor, about the DevCamp. I would have to see what our options are for being able to make it available. I think the technology that we're using, you can actually make assignments like that visible to peer students as well, so that folks can give feedback. Is that something that people would be interested in and willing to have what you're posting and sharing be visible to the other folks who are in the DevCamp? Cool.
Nice. Some yeses. Cool.
Nods and twinkles.
Nods and twinkles. If there are any no's, just let me know. If that isn't something that you want to do, but otherwise we'll work on making that visible to folks. And also, yes, send and can share their info in a discussion.
Good notes, Ben.
Yeah. Okay. Oh, yes, that's also a great question. So we were going to make sure that you guys knew, we past DevCamps, we've left content open for 14 days. And what we're going to try this time is actually leaving the content open for 30 days so that we know there's a lot of content, and we know that folks are at different parts of being complete. And we'd like to see if that is a good amount of time for everyone. So you'll be able to access all of that content for 30 days after the DevCamp. So I'm gonna go let Arthur know that we're ready. If you guys want to talk about anything else, be right back.
Yeah, I have a quick question while we're waiting.
Sure.
Just to continue on what we were talking about with the holding the data by the nodes, it said the DHT of Holochain app makes sure that there are always enough nodes on the network to hold a given datum. And so I guess I was just trying to understand that better, like what's the mechanism for that? Because like say, for example, there's not enough nodes hosting an application.
Mm-hmm.
Yeah.
Yeah, obviously at a certain point, well, always at a certain point, it's limited by the number of nodes in the network. So some of this is still theoretical in terms of implementation, but of course it should work in such a way that where if you set that there should be 15 copies of a entry in a network up until the point when there's 16 nodes, then all 15 or less nodes are going to hold a copy of a given entry. So, and then as you go above 15, if that was maybe the number that was set, then you might start to operate on a different value. You might operate on a percentage value rather than a strict numeric value, where you could say I want like 10% of the total number of nodes to be holding this, and I believe that this should just be a property of the ongoing gossip between nodes that would the DHT and the sort of like algorithms of the DHT should actually be able to check and calculate the number of copies that it can find on the network. So it should be kind of doing ongoing calculations in a sense. And if it sees, in particular, there would be events that would trigger a recalculation or something, like when a new node joins the network or when a node leaves the network. Those would be moments when the algorithm should maybe do a recomputation and see if there's any gossip that it needs to do in order to even the distribution of the data in the DHT.
Okay.
Karan, just can you give me a brief idea on how the consensus works for the Holo DHT? A little bit on the consensus for Holo DHT.
Yeah, there's not particularly a requirement for consensus. There's that's somewhat bypassed by a couple of the properties of the DHT itself, which is one, that it's content addressable storage, which means that if I write the same the same content as you write, then technically those just result to the same hash, and so they actually live in the same. They live and resolve to the same address. So there's not really a conflict there. And then if the data is different, then it just gets stored at a different address, and so there's also no conflict there. There is more complexity when you get into the question of updating an entry and removing an entry, because then you're dealing with these questions, I guess, yes, such as if I update an entry and you updated it. And there you do get into a little bit more complexity, where we're doing some work into detailing the types of algorithms that would be used for conflict resolution, like one called the CRDT, which we could provide. We're going to be like kind of providing some more information about that coming soon, because it's something I think that is a very important detail of Holochain, and we need to provide more resources about that.
So okay, the core. Okay, go ahead.
Cool. Thanks, everybody.
Yeah, great questions. It's really great to see all your faces and to hear what kinds of questions you have and to engage.
So, yeah. Oh, that was just thank you. So, Bear, do you want us to talk about some of these Events Goer 4,000 submissions now, or do we want to introduce Arthur first?
Forget Arthur. Let's talk about the submissions.
Yeah.
Real quick.
So far, wait, no, I think you should talk about it, because I think you'll be more excited.
I'm pretty stoked. So we've got 5 submissions of new Events Goer 4,000s with new names, including Peter's Grand Adventure and what is that? Excitoplasm. A lot of points there. 100 points to Excitoplasm. We're stoked to have these submissions and to get more from you. If you want to keep adding them to the repo over the course of the month, for those of you that are going to keep jamming on the course material that's still available, keep putting it up there. I think that it might actually be a really cool resource in the future to be able to have a bunch of different stuff that people can plug around with at the next DevCamp and take different parts and make explore bridging potentially between apps and combining zones. Could be really fun result that we could actually build something that people could play with that way. And just want to say thanks for doing that, and keep plugging away at it. And then we can welcome Art. And Art, do you want to? Art doesn't really need to introduce himself. Sorry, Sven. I can't help it. And yeah. So if anyone has any questions for Art about Holochain and the vision and Scepter and metacurrency and how it fits or anything like that, now is a great time to ask. Need more specific questions than everything.
Correct.
Can I ask a question?
Yes.
Okay. I'm just curious about if we develop the H app, and how much does it cost to put the our on Holochain? Does it take just the initial cost or running cost? Tell us, shares how much. How much will it cost to put our HF on Holochain? Is it make sense?
So, as I understand it, you're asking how much it costs to run your app on Holochain, and Holochain is designed purposely without a currency because it is so lightweight and efficient that you can run a node only for your app. It's not like monolithic like Ethereum or a blockchain where you have to run everybody's app just because you're running a node. You're running just the one that you want. And synchronizing with other app users. And basically the deal is you have to serve yourself plus a little. And that takes that's a small enough load that we think that you don't have to pay people to host themselves plus a little. They're willing to do the plus a little. It's our belief that they're going to be willing to do plus a little so that they get to own their own data and control their own identity and take the big corporations out of the middle of everything, so they have their own incentive to host themselves. Just to give you a sense of the scale of what I mean by efficiency or load, because for many people coming from a blockchain mentality, it's like a crazy idea that, well, you have to pay people to run these things because they churn and burn your machines and blah, blah, blah. But that's because of the global consensus that blockchain is built on, and Holochain does not require consensus. That was a question asked earlier, so we can come back into that if need be. But just if you were running, let's take a real application like Twitter. If Twitter migrated over to Holochain but still had the existing user base of 330 million active users tweeting on average 1.1 times a day, that's 363 million tweets a day. On Ethereum's best day a year ago, January, it did 1.8 million transactions in a day. So that's, pretty far from the scale that you would need even just for the tweets, not to mention retweets or likes or, direct messages or the other kinds of things that go on. If you were running this as a Holochain app, and let's say you put a redundancy factor, you configured your DHT to have a redundancy factor of 100. So you're going to have 100 copies of every tweet out there to make sure that copies are online on the DHT. That means you would need to validate, as a node, you would need to validate 110 tweets a day. So every 13 minutes, you would have to do about 2 milliseconds of validation processing. And that would be the computational load on your system. We don't think you have to pay people for that.
Oh, I see. Thank you.
I had a question about how do you envision a bulk operation happening on a Holochain for doing some kind of mass updates across the DHT?
I'm sorry, how do I visualize doing a what?
A bulk update. A bulk update on for some kind of operation across a bunch of data on the DHT.
I'm not quite sure why you would be doing a bulk update on a bunch of data on the DHT.
Say you noticed a mistake or something like that, and you just needed to do a bulk operation of some kind to fix a bunch of data on a particular app or something like that.
Well, first of all, you can't do any operations on the DHT directly. All operations happen on your local chain and then propagate to the DHT. And that's part of the data integrity model of Holochain. It's why we don't actually need consensus, is that there is no such thing as global state. There's only local state that can be globally accessed through the DHT. And so it simplifies validation significantly. It's why we don't need consensus, because the focus is on validation. So for you to do a mass update, I'm trying to understand a scenario where, first of all, enough of the data would be under your purview or authorship or control that you would be allowed to be updating it. I mean, and then you would basically be writing new entries to it, to your chain, and then those things propagate to the DHT. And when they propagate, I don't know if you guys, I'm pretty sure you probably didn't make it to CRUD functions where you actually do updates or deletes or anything, because not even all of those are working in this version. So if you do an update of a particular data element, it marks the old element deprecated, puts a pointer to the new element that replaced it. And then those things happen just in the nodes that are holding the old element, right? Because not all nodes have the whole DHT. And so these things would replicate one at a time as you write to your own DHT, to your own source chain. We haven't done much scalability testing on the Rust version of Holochain. There are parts of the Rust version of Holochain that should be more efficient than the Go version. However, we've also been running into some things that are less efficient. So we need to do scalability on testing on the Rust version. On the Go version of Holochain, the best scalability testing we did was for a guy that was in Melbourne, Australia, working on a smart meter app, and he imported millions and millions of records from smart meters that take electricity readings like every 5 minutes, and so that was the first time we were doing like real scalability testing with updates and all that kind of stuff. And he was finding now admittedly there weren't like millions of nodes running on this on his app, right? His DHT only had like 5 nodes that were on it. So replication wasn't a problem. What was happening was, like, when he was importing to his source chain, he was and querying on the source chain and doing operations like that, he was finding some weird speed behaviors that made it seem like what I mean by weird speed behaviors was like there were certain operations that were seeming to take longer to read from the DHT than to write to the DHT, when he would barf 250,000 records in there and that kind of thing. And sorry, not to the DHT, the source chain. But nonetheless, these things were happening in, he would spit 250,000 records into his source chain in a matter of like 2 or 3 minutes. And, if you were to try to do this on a blockchain platform, like when we were benchmarking against Ethereum, for us to write 10,000 Ethereum addresses to an ICO whitelist, for example, takes 37 hours to complete the process, because of actually how much of your computation you can get into each block. So 3 minutes versus 37 hours for a much smaller bit of data just gives you a flavor of the differences of those things. Does that help answer your question? Because you don't really do mass update operations on the DHT.
Yeah, no, the ICO example is good about like updating an ICO whitelist. That was a good example.
Okay. So. All right, cool. Oh yeah, and I forgot to tell you, on Holochain, that took 1.2 seconds, and on Ethereum it was 37 hours. Yeah.
So there's a bunch of questions that have come through on chat, including some things based on earlier commentary. And Bear and I are a little concerned about whether we need a little stretch break to help folks be able to listen to this next section, because there's been a lot of talking and a lot of listening. Do we want to go ahead and have a quick stretch bathroom break and then come back and we can get into these questions? Yes? No? Yes?
I just want to ask a question. Are you saying that Holochain is better than Ethereum?
I'm not saying anything about better. Better for what? Like, at the moment, you can.
I like our t-shirts better.
You can make more money mining Ethereum right now than you can mining Holofuel, because there is no Holofuel. So it depends. Better for what?
All right. So let's just take.
Mostly it was no's, or at least in the chat, it was mostly no's.
The chat was all no's, and I didn't see anyone seeming like they really wanted to. Does anyone?
Got it. If
anyone really wants a break, go take a break, and we'll just keep going. It's recorded.
Yeah.
You can catch the recording.
Exactly.
Art, I think Kevin had his hand up before.
Yes, thank you, Eric. Oh, go ahead. Sorry. Go ahead, Mickey. What's up?
Well, it's just that there are questions that are about the prior topics that are in the chat window. So I just wanted us to back up a little before we keep going down other things. Can you hold on to your question for just a sec? Thank you, Kevin.
Definitely. Yeah.
So Thomas was just asking a follow-up earlier of, can the plus a little happen in a standard Chrome browser, or it had a separate software like how BitTorrents work? Brock.
Yeah, you're saying that was typed. I'm looking for that question.
Mm-hmm.
But
yeah,
in any case,
I'm just asking, like the pay it forward sort of part there. Can that happen in a normal browser, where if you download one, then you upload 1.1, or are you envisioning that's all going to happen in a torrent like piece of software that will be separate, and that we slowly migrate over the years? What are you envisioning there?
I'm not. I guess I'm actually not still understanding the frame of the question. I want to make sure I'm actually answering the question you're asking. So, what is it you're trying to do, and that you want to do?
I'm just asking, as the peers download website data or data from the distributed hash table, and we were just having a previous conversation about how, like, the idea is that with the Twitter example, if you download 100 Twitter tweets and you'll upload 110, or an extra 10%. Is that going to happen in a normal browser, like when someone's using the browser on their phone or something, or is that going to happen in a separate piece of software, or is that only in the hosting? Or I'm just trying to get clarity on.
Okay, so I got what you're asking now. So, Holochain, unfortunately, the answers are varied in that Holochain is designed to be peer-to-peer. It is the piece of software that stores the things in your local piece of the DHT, your little shard of the DHT for whatever apps that you run on Holochain, right? So you install Holochain, you can then install additional apps or write additional apps, and you store the things you write to your source chain, and then your little piece of the DHT, which basically is related to your address in the DHT space. You're going to store data that is near your address based on the nearness algorithm. And so that's, it's a little bit, it's not really BitTorrent-like, in that BitTorrent doesn't balance itself. What BitTorrent does is if you are downloading a file, if you're downloading a video on BitTorrent or something like that, while you're downloading it, and you may keep seeding it after, that kind of thing, you're sharing stuff that you've downloaded. But Holochain is a different kind of DHT. There's a few differences. It's a self-balancing, self-healing DHT. So it actually pushes data out to nodes rather than you only pull data voluntarily, so that it keeps the data alive. So when I first came on, Connor was talking about sort of the resiliency number and how things change when nodes leave the network and that type of thing. So because it's self-healing DHT, it checks every once in a while to see how many nodes are holding different pieces of content, and then basically recruits more nodes to hold it that are near it, so that it keeps the content alive even as nodes are coming or joining the network or leaving the network over time. You can't do almost any of this in a browser. Browsers suck at having persistent local storage. Even the local store isn't reliable over time. People lose it when they do browser updates or clear caches or different things like this. However, with Holo hosting, you can access it as a client basically in the browser, and then you have hosts that are doing basically your share of the source chain and DHT work, and so they're extending you virtual Holochain space essentially by doing your portion of the hosting. Does that answer the question?
Yeah, it does. Basically you're saying that, like the Holo hosting will do that, take that load initially, but maybe in the future it might even happen in the browser as well. Like it depends.
Well,
I can see it in different directions.
You know, if Mozilla agrees
Yeah.
to build it into Firefox, then yes, it can write directly to this file system and will store things and, you know, that kind of thing. But you know, without a deeper integration with the browser, browsers are kind of designed to prevent you from making things stick around.
Yeah, no, that makes sense.
Thanks.
Yeah,
Kevin?
I just have a.
Oh, sorry. No, go ahead.
Yeah, yeah. So yeah, I have a question regarding the server discovery process. So if we have multiple nodes hosted, P2P nodes hosted all over the world, so how does Hollow helps discovering the servers that are actually hosted all over the world? I mean the server discovery process for Hollow.
So there's a couple of options on this. I'm actually going to tell you the most basic scenario. In the most basic scenario, you're a newcomer to the app. You don't have a source chain established somewhere. You're just opening up a web address in your web browser, and we have to connect you to a host, right? So the old internet is somewhat centralized, right? They expect DNS to have an authoritative DNS server and then to resolve to an IP address and that kind of thing. So when you type an address into your browser, something has to happen. We have to actually send you to a place. What we do, you know, we keep using this Airbnb example just because it's fun. If grandma, who is not installing next-gen crypto software like Holochain on her computer, if she wants to use your Airbnb app that you've just written, she expects to be able to just type it into a web browser, right? And go to Airbnb.org and shop for her vacation property. And so what happens is Airbnb.org actually resolves to loader.holo.host in terms of a CNAME alias. And we load in a JavaScript file that takes a look at the address that's in the menu bar, calls a service that converts your domain name to an application DNA, so we know what application she's trying to load. And then we get, according to different service tranches of hosts that match that application's hosting requirements, we get 5 hosts back from our system that we pass back into grandma into these JavaScript tools. The reason we do 5 hosts is because we don't know if hosts are going to stay online. And we want to manage, we want to be able to wrap requests that are happening basically in a protocol for if something times out, we can switch to another host and make sure that you're not just left hanging. So the way that those 5 hosts are selected is basically a process which is kind of randomized from the inputs from 3 sources. And what I mean by that is the host's address itself, the list of tranches that we've provided from collecting performance data about the hosts, and then the hash of the request coming from from grandma in this scenario. And so what happens is if there's 138 hosts in the first tranche right now that we could send it to any of them. We take the hash of grandma's request, and which has, by the way, a signature in it. So it's going to be different every time things come. This is not like a request that's always the same, so that it will become so that it's weighted. We take the hash of grandma's request and we do a modulo 138 on it. So let's say that comes out to 77. Then we grab the 77th host and the next 4, and that's who we give you back as your 5 hosts. So it basically creates a round robin algorithm without us actually having to track what we've just served out by randomizing it through the hash algorithm. And the reason that this is important is because the services that do this run in 160 data centers around the world. and they can't keep track of who the other data centers are serving out. So even the centralized parts of Holo, which do this resolution, are pretty decentralized.
Okay, the state resolution. The state resolution that Holo performs.
I'm sorry, can you say that again?
I mean, the resolutions, you mean the state resolutions that Holo performs?
I think there may be some echo back that's cutting you off a little. What
I mean, the state resolutions are the I'm talking about the state resolutions of the Holo that Holo performs.
The state what that Holo performs?
The state resolution.
State resolution?
Yeah.
I don't know what you mean by the state resolution. Are you thinking?
I'm talking about the conflicts that how. So when we do a commit entry, so at some point, so if we have a conflict and while committing, so how do you handle the state resolution? Like, is there a need to handle the state resolution, or like it's taken care of by the DHT itself?
So I think this question is coming from the perspective of, for example, the Patricia trees on Ethereum of a global state that all the nodes are managing. There is no global state in Holochain. There is only local state with global access to discoverability. And so what this means is you kind of have to undergo a little bit of an agent-centric mind shift in the way that you write your app. So for example, if we were writing a currency in Holochain, since most people know about currencies on blockchain, it's a useful example, plus it's one that people are concerned about state and double spends and that type of thing. If you're writing a currency in Holochain, what we would recommend you do, and it's the way we're implementing HoloFuel, is that you implement it not as an inventory of tokens, an absolute inventory of tokens, but instead you implement it as accounts, each of which have state. So each agent has their own account. It is, in fact, the history of their source chain. And as you write new commits to your source chain, you can replay your history to determine your current state, your current account state. So when you and I want to do a transaction, Manish, we send each other a message to build the transaction, and then we each sign it and provide a counter signature. So we countersign it to each other's chains. Now I can't alter anything in this transaction nor in my history, because anything I do will break your signature. You can't alter yours because it'll break my signature, right? And we're publishing our headers to the DHT, so we can't alter anything in the chain anyway, because once a header's been published to the DHT, it has hashes in it which will break. So it's basically an immutable account record. And so when you and I do this transaction, my copy of the software of the currency app audits your chain, your copy audits my chain, and it makes sure that I have the 100 credits that I'm sending you, right? And then when we both sign this transaction for 100 credits, we're both accountable for this transaction. So unlike blockchain where it's a single signer spend, if I'm sending you 100 credits and you agreed to it, you're also agreeing that this is not a fraudulent transaction. The reason this is important in this scenario for HoloFuel anyway, the way that we've optimized validation, is we can basically go down your chain, or rather go up your chain in the way that I've been making hand motions so far, replaying your history, confirming signatures, and make sure that each transaction is valid. And as long as you haven't been flagged as a fraudster, and what I mean by that, have you guys talked about warrants and Holochain's immune system? Okay, so when things fail validation, you can have your application respond a couple different ways. You can just have it, wait, let me just make sure you guys also know. Yes, you validate these things when you write them to your local chain and to your copy of the DHT, and then your copy of the DHT gossips it out to other DHT nodes. So you are already are validating it twice before it even leaves your computer. And then for every other DHT node that's supposed to store the data, they have to validate it before they can make the data available for serving out, which basically makes the DHT a randomized mutual enforcement system, right? Where you don't know what peers are going to need to validate your transaction. And if anybody finds a fraudulent transaction, one that breaks the rules that we all have a copy of because it's the very first entry of your chain, right? Every application, the very first entry is the rules, which include validation rules. It's your application code, it's the DNA. So we know we're all operating by the same set of rules. And if I can see that let me say this differently. Manish, you and I just did a transaction, but Kevin isn't running a node that has to validate it. If he sees, wait a second, he didn't have those credits that he just sent. When I replay his history, he didn't have 100 credits to send. All he has to do is take my transaction and wrap it in a little thing we call a warrant. It's basically just a little envelope where he flags it as fraudulent, and then he can gossip the warrant. And every other node has to only trust their copy of their DNA, and they can verify this warrant and then block me from the system. And basically, by cheating, I just forked myself into a different reality that nobody else will play with me. And the network can protect itself from bad actors that way. So we don't have to reach consensus. We just have to do validation. And I think this is one of the confusions in general in the blockchain space. There's been way too much focus on consensus. You can run whatever Bitcoin miner you want, but everybody has to run Bitcoin Core to make sure that they're not forking themselves into an invalid chain state. And that's all that happens in Holochain is if you take an invalid action that the rest of the network won't acknowledge, then you've just basically isolated yourself from the rest of the network. Nobody has to agree to play with you. And it doesn't matter whether 51% of others have agreed, as long as there's one honest node who can discover the warrant, who can discover the problem and circulate a warrant, then all the other honest nodes say, no, we don't want to play with that person.
Okay, got it. That was a great explanation. I was expecting something like that. Yeah, this is great. Understood completely now. Yeah, awesome. Yeah.
Awesome.
Cool.
Kevin, you were raising your hand earlier.
Yeah.
Yeah, where to begin? I have a couple questions, but first I just want to say I'm a huge fan of the MetaCurrency project, so it's a real honor to be here. I'm really excited about everything that you all are doing. It's just an amazing team that you have. It's been fantastic so far, so thank you all. But yeah, I was going to ask about membranes, interoperability, and how bridges are going to work. I was hoping to get some more kind of nitty-gritty details on how that's going to function.
So one of the things that we've tried to do, and I say tried because I'm not sure we've fully succeeded yet, is to simplify the security model for calls to an application basically down to one approach. And this approach has to do with capabilities tokens. Did you guys talk about capabilities tokens yet? A little bit? So you can write an entry, it's a private entry, to your source chain, which grants particular permissions to a particular key or set of keys. And you can say what functions they can call, and whether those function calls are with fixed parameters or wildcard parameters, variable parameters. And so basically a request can come in to an application and make calls straight into the functions in that application to read data or even write data. And basically this is the way that we configure bridges between applications. You create this capabilities token, and what it essentially is it's like registering an API key for the other application, so that when it sends requests in signed by its key, it can be validated that it actually came from the key that was authorized to make those calls, and then pass those calls right in and return the data, call back with that data. And so you can set that up on one side where you're calling in and just doing the callback, or you can set it up on both sides and the apps can both talk to each other, that kind of thing. So that's basically the way application bridging works, and it happens on your local machine. And the reason that we only bridge locally has to do with the complexity of permissions. If you try to abstract permissions for an application across a whole network state, it's very complicated.
Yeah.
But if I know that I am me in this context and I am me in this context, and I can bridge to only myself, then I'm only going to get the permissions that I have in this context. And that way we don't have to worry about creating really complicated abstract permission models, which tend to create big security holes, that everybody can only be themselves in the app, and that's the only permissions you get.
Great. So just to make sure I understand correctly, if there's a membrane, it's got its network of people and that has its own set of validation rules, and there's another membrane and someone in that membrane wants to request data that has been validated within my own membrane, they're just calling then and asking me for that permission set? Is that how it's working? Or I just confused, sorry.
It sounded like you were saying two different apps. So distinct apps are distinct networks, right? The DNA hash of your application is part of the network encryption salt for that application. So nodes in one application cannot talk over the network to nodes in another application. They are separate networks. So we have separate peer-to-peer encrypted networks. So if you want a person from app A to be able to talk to you, then in app B, then they have to run app B locally on the same machine.
Okay.
And bridge between app A instance and app B instance, and then their app B instance is talking to you. And they can pass requests from app A into themselves in app B to make the calls across. Does that make sense?
Okay, yeah, that makes perfect sense. Gotcha. Okay. So that does kind of help with encouraging then people to want to host more types of apps.
Yeah, anything that you want to run,
interact with, you have to be hosting. Okay.
Yeah, exactly.
Great. That's awesome. That's fantastic. Thank you.
Thomas, did you want to ask about licensing?
I was just sort of asking, that's basically the same functionality that would be used for licensing. Is that correct? Like where you'll provide a sort of a token to do certain things, and then the token gets revoked at the end of the day or when the license is finished, or? Can't hear you.
I'm sorry, I'm muted, right, on my hardware. So you're talking about software licensing, or?
No, not software licensing, just more how sort of, usage types or I'm thinking about like the medical records example where you give your medical records to the doctor for an hour, and that will be provided via, you give them a token for an hour or something, and they can
Exactly, you create a capabilities token, and you can revoke that token later. I'm not sure whether we got expiration dates into the tokens. They may have not made it in on this cut, and it's actually much easier if you have to explicitly revoke the token than if we have to imagine that it. Anyway, so I don't think we have expiration dates in, so you would have to have your app actually write another token or basically a revocation of that API key that you just gave them, essentially.
Yep. And is this all going to be specified in the usage type part of I saw that bridging example on the on YouTube put out by somebody, and it had a usage type field. Is that where that's all going to be specified? Or is
that was the Personas app?
It was,
you were
yeah.
saying?
Yeah.
So, or the HoloVault Personas app? Yeah, that usage type thing, he didn't implement the way I was intending. He sort of put a description about why they wanted the data, and what I want in it is actually what's called a link contract. It was first created in XDI. I don't know if you're familiar with extensible data identifiers, but they had a way of basically issuing you a token that had a link contract, basically would link to a computer readable version of a contract of how you were allowed to use the data, right? So I am requesting so HoloVault is used for your personal data store, and think of it a little bit like OAuth. Like you go and you log in using Facebook or Google or whatever, and then the site you're logging in is saying we're requesting your email and your first name, last name, and username or whatever, right? And it's pulling that from the OAuth source. In this case, the OAuth source is you in a personal profile vault that you manage, and you control these access tokens to, and you can revoke those tokens later. But what we want to do is actually use link contracts to have it be specified how the data is being used. In other words, I'm requesting your address for shipping, and it will be a part of our delivery records, a permanent part of our delivery records, private delivery records. Or I'm requesting your username, and we're going to publish that publicly on the DHT, so that what data is getting what levels of exposure and how it's getting used. And none of that is formalized in Holochain yet, even in the version that he just created that was, a kind of a demonstration of this stuff. It's not actually link contracts. It's sort of like, why are we asking for this? Because we need to know it for yada yada, but it's not actually promising the level of exposure and the amount of time it'll be kept. And the reason I think we need to do link contracts is for GDPR compliance and personal privacy compliance stuff. Cool. Sorry, I don't mean to go on with a lot of detail in these things, but you get me rolling, and then
that's part of what we like about you, Art Brock, is often it's fun to listen to you go on and on. So there was Sven was making a comment about hosting. Is that, do you want to talk a little bit more about that?
I see Sven posted about like 1 to 10 or 1 to 50 redundancy in case nodes go offline. And I'm hoping that the self-healing aspect helped address that. So it kind of depends on how fast your nodes are going offline. And, like if 10 of them, or all of them are not dropping within some very short window of time, then the network should just keep healing itself. But if you have a very volatile user base, you may need to increase your replication factor. Searching and indexing. Somebody was asking about. That was Christopher. Well, do you want me to answer that one? Should I?
Yeah.
Okay. So a DHT is a horrible space to search, right? Because when you're a developer, you're used to having all that information right there in your hand, kind of, right? Like you're used to having it on a centralized database or a centralized blockchain. And what I mean by centralized in that case, it means everybody has the same copy, right? There's multiple copies, but it's all one. So you can just still count on looking at it locally. In Holochain, which is on a DHT, there may be no node that's holding all of the data. So there's not necessarily one centralized way to do a search. What we built for the previous version of Holochain, and we have not rebuilt yet in the Rust version yet, is we called it Holodex, but basically an indexing application that is an application plus a stub that you put, a sort of stub mixed in code that you put into the application that you want to index. So for example, if it says in the question something on the scale of Twitter, so we had, this peer-to-peer Twitter app we called Clutter on the previous version of Holochain. If you put in the little little stub in your Clutter app, and then you run a Clutter dex basically, and those are two separate applications. So in the previous question where we were talking about application A and application B and bridging and blah, 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 what happens is you have certain nodes that volunteer to be index nodes. It's also possible that with Holo hosting, some of these apps may get paid to run some nodes may get paid to run these apps. You may end up having to pay people to do this. If you're running like a YouTube service, right, you're not going to serve videos from your friggin' phone, right? You're going to need to segment this functionality such that there are nodes that are set up with the bandwidth and large storage to store the stuff. And then there's like a client app that can search and upload and that kind of thing. So what happens with this indexing thing, with the little stub that you put into the Twitter side or the Clutter side, when you post new things, it not only publishes it to the DHT, but it sends a copy to a node that has advertised itself as an index node. The index nodes are, since that's a separate Holochain app, they're all synchronizing with each other. Doesn't matter which index node you send it to, they will all update each other anyway. Because they are in a non-sharded DHT. That's in a space where you've turned sharding off for the DHT. So each of the index nodes actually does build a complete index of the space. So you send your tweet to them, they may or may not keep the tweet. They don't have to keep the tweet, but they do need to index. They do need to build indexes of it. So then when you want to search Twitter, then you actually you have to talk in Twitter. You send a message to one of the nodes that is an index node with your search query, and it bridges to the index app locally and returns the result back to you. There's a bunch of different cases where you want to do this sort of architecture, but it's for when you really have an imbalance between what some people are willing to carry and what others are willing to carry, and you segment your application appropriately. But that gives you a way to search nodes that actually have built complete indexes. In the new version of Holochain, we are looking at integrating some of this a little bit more. And in fact, on the old version, we did tap into some of the indexing functions that were available in the store we were using for the local data. We may make it possible for you to query locally with indexing functions, and with the new RR DHT that we have not released yet. We have a rough version of, but it's not Kademlia. It's not the Kademlia DHT we used in the previous version. It's a custom one that we've built in which it allows you to tune the range of coverage of the DHT that you want. So you could volunteer to be an indexing node just by saying, I'm going to cover the whole thing. I'm just going to store it all. And as you know, there are plenty of companies out there that make their business collecting data. And so it may be that there are companies that will run full host nodes for you, full index nodes for you, because they want copies of all the data. And then they're going to do data analytics on it and do other stuff, which of course isn't necessarily in the spirit of privacy in which you may be building a Holochain app. But then again, it may be. It depends on your use case. If it's Twitter, you're intending these things to be public. Sorry, long answer.
What do you see as one of the biggest non-technical hurdles to bringing this to the masses?
Well, I have to say that the agent-centric mindset, that like the shift that you actually have to make, is very foreign to people. It's like I'm very grateful that projects like Bitcoin and Ethereum and all that kind of stuff did come out and kind of prime people's consciousness for decentralization. But I also feel like we're swimming upstream against a strong set of notions that have already been formed, have already congealed about how things work and what's possible, such that it's actually really hard for people to see this and see that it's possible. And I think in the end, we really just have to prove it by running all of these things and having nobody be able to actually break the security on it, even though they think that what we're doing is impossible. It's like most people, what they assume we're doing is sharding a blockchain, which is hard to do because blockchain is based on global consensus. It's data-centric stuff where everybody has to agree about the state of the data. Where when you start off with agent-centric, you never needed the global state to begin with. So we're not sharding a global state. We are validating changes to local state with a global view on it, global access. And it's just such a kind of like inversion of the parts that most people don't see that it's even possible. So I think that that's one of the big hurdles, is that everybody just thinks we're full of crap because they think what we're doing is impossible. And yeah, I don't know. I mean, I think there's also missteps that we could make, if we do release things with half-baked security and that kind of thing, and then people actually think that they can prove that this approach is insecure, even though it may have just been that this whatever encryption algorithm was insecure. And we're not claiming to be cryptographers. We're just building peer-to-peer software, So there could be some problems like that. But we're trying to make very conservative choices in those domains and lock down the security pretty hard.
Okay. So this is it. This is the last really good question for Arthur Brock for right now. So make it a good one. Anybody?
Let me just do a really fast one while people think of one. Sven said, as applications become more complex, a small incentive for people running a host. Yeah, people running hosts do get paid in HoloFuel, but people running a peer in Holochain do not get paid because there's no currency in Holochain. That's part of reducing the overhead. It's just about everybody carries their share. But yeah, we absolutely hosting. Yes.
Are you finished saying what you wanted to say? Yeah. Kevin?
Yeah, and Thomas had mentioned as well something about randomness, and that's something that I'm incredibly interested in as well, especially when it comes to potential for gossip protocol and validating DHT, kind of grabbing random subsets of the population, either pushing or pulling either direction. Is there something like that planned to be implemented? I do remember reading something about randomly validating data, like choosing the agents that validate, or is that not true?
The way that the validators are randomized is that the data is stored in the DHT by hash, and the nodes that are near that hash are the ones who store it. And since you don't know what the hash of your data is going to be until you've produced it, right? That's what randomized means. It's not true random. It's unpredictable, right? It's
right.
And if you need to force certain things to be unpredictable, like when you're doing a transaction with somebody, that kind of thing, if you include in it, signatures of a portion of the data, if you actually embed that into the transaction, it's very hard to do anything, unless you're in control of both parties. I don't know what your signature is going to be on this data. I can't control the outcome that this is going to be, so what hash it's going to produce. And these things, proof of work is all about being able to try to predict a hash or get a hash down to some predictable range of hashes. And so you're basically talking about proof of work complexity to try to do any kind of setting the deck of who's going to who's going to validate something. And even then, it's just for one data element. It's not like taking control of the network.
Right.
So
that makes sense. What about with the advent of quantum computers and having an uncomputationally unbounded adversary?
I don't know that quantum computers, as far as I know, quantum computers still don't do hash prediction. They could do key breaking because they can resolve to a single state, but you're not trying to get to a single state with the hash. But we're not making holochain quantum proof right now. We haven't built the cryptography that way. But the cryptography is modular. If we have to replace the cryptography with a more quantum proof solution in the future, we could do that. But
okay,
yeah,
I was just asking because I believe that holochain is the only infrastructure I've seen thus far that could be quantum resistant, at least potentially, compared to anything else. Anyways, they're all kind of hopeless. So awesome. Well, thank you very much. I appreciate it.
Let me just say one other thing. When you brought up random at first, the direction I thought you were going, which I think may be a useful thing to know, which is validation in holochain has to be deterministic, right? Like anybody who's going to try to validate your action has to be able to repeat what you did to produce your action. So if you're playing some dice rolling game or poker game or whatever, right? They need to know the source of randomness that was used in producing your action and use that same randomness, that same seed for the random generator or whatever. And so there's a bunch of interesting strategies that can be done there, but like one of the most basic things that we're looking at doing is something that's sort of akin to a one use pad. Do you know what I mean when I say that for encryption purposes? Yeah. So imagine you and I are going to play a backgammon game. And we start off by creating a private entry that has our next 100 dice rolls in it, and then what we do is with each turn, you take each person's next dice roll number and you hash them together so that I couldn't control in advance my dice rolls and you couldn't control yours. You create these random seeds, we hash them together, and that way you get the next 100 dice rolls, but you all agree about the source of entropy for those dice rolls, for example. So you can embed randomness in a lot of interesting ways.
Yeah, that's a great idea. That's cool.
Okay, good. There's so much to talk about. And we really appreciate that you all have joined us. Arthur, thank you for joining us for this session. I have just a couple of quick things for us to wrap up. One is day 5 content is up and available, and it does include a little bit more detail, actually more detail on membership and membranes and bridging. And then we have a growth strategy session coming up at 12 p.m. UTC. So later today, whatever day that is for you, that is in the Moodle in our DevCamp site for day 5. Also, we will have future DevCamps, intensives, other opportunities for us to connect with the dev community, and you all are a big part of that. And we look forward to more future opportunities to connect with you both in person and online. And so just know that if you are on our mailing list for DevCamp, then we will be using that to communicate as well as through our other standard social media channels. And if you're not on that list, then go to holo.host/devcamp so that you can make sure that you're on our developer mailing list. And then also, we really just love you and appreciate you. And we mean that. It means a lot to us that you're spending the time and the energy to dive into Holochain, especially since it's still real early. And your experiences and diving in and excitement mean a lot to our dev teams in the work that they're doing. And so thank you for all of that. Please note that as of now, you do have access to the final quiz and also the feedback survey. And the final quiz, some of you already did that like a couple days ago because we didn't know it was visible. I've deleted all of those because the final quiz is actually updated and changed. So please feel free to take the final quiz again. It's not that many questions, but that really helps us. and you to see how far you've come just in these last 5 days. And then the feedback survey, I know we talk about feedback, but it really does matter to us. So if you haven't been able to complete that yet, please do. And anything else, Bear?
Yeah, I want to say that we'll send out a invitation to a Zoom call next week, or a couple of Zoom calls at different times next week, for people to tune in after you've settled on this experience a little bit, to see where you might want to fit in. So a next steps opportunity. So this is what I'm working on. This is where I want to be playing in the Holochain community or in the ecosystem, or this is the project that I want to be moving forward with. We'll have a couple sessions and we'll get where you're at with that, and then make sure that we funnel you into the right spot, connect you to the right people, the right partners, the right conversations to be able to move forward effectively. We've got the next feedback session. We had a problem with the one this morning. There was this morning my time. So we're doing it tomorrow my time. Some of you it's today, 12 p.m. UTC. And I wanted to check in. I realized that we didn't have a good session for people on the West Coast or like the East Coast necessarily. So I want to see if there's anyone that none of those feedback sessions worked for and who would like to make one if it was midday EST time. Okay, great. Then we keep it the way it is. Awesome.
Cool.
Thank you.
Thank you. Any last words, Arthur Brock? Oh, you're muted again.
Sorry. Yeah, sorry. I mute myself on the hardware and somebody muted me in the software. It's great to see all your faces. Good to meet you. Good to see you again, Victor. Liked your blog post recently. Yeah. Cool.
All right.
Look forward to meeting you, Thomas, in Australia and your crew there.
Art, do you actually want to close with the humility check-in thing?
Sure. How far through the DevCamp are they? One more day? So, yeah, in case you're feeling like parts of this are still shrouded in mystery, or you don't banging your head up against some challenges, let me just say that there ain't nobody who's an expert in this yet. Like, we're still figuring out what the best design patterns are and how to even use this kind of stuff well. And especially when it comes to building it on Rust, like the Holo team that's been building on Rust have been bumping their heads against lots of different things. And part of that has to do with some of the stage and maturity of the Rust build, but also just, we haven't quite gotten it to the level of usability and accessibility. So like, don't feel stupid for anything that's confusing about this, and hang in there. It's like you're in the right place. This is still very challenging work. There's nobody that's an expert in it, really.
And I think that's part of what Mickey's saying. We really love you and appreciate you. It's like, this only works because you're a part of it, and your participation is what actually makes it real. You're building with it. You're giving us feedback. That's why we're so obsessed with it. And your contributions to the ecosystem, wherever they may be, is what will actually bear this technology into being and create a different world with it. So that's why we really value your participation, and see it. While it's easy to forget while you're looking at code that it's like really revolutionary stuff, that if we can pull this off, it's going to be a huge difference. And all those little symbols on your computer screen will have changed the lives of like potentially billions of people. It's kind of crazy to think about. So thank you all for being here and for participating in that process with us.
Bye for now.
Thank you.
Until next time.
Thank you. Thank you very much.
Thank you.
Bye, everyone. Thank you.
Thank you very
all
much.
for your participation.
Bye-bye. Thank you all.
Thank you. Bye.